As AI systems are becoming more and more present in our daily lives, the risk of those AI systems failing in some way also increases. Because of that, myself, along with our applied AI research team here at Neudesic, has been working on a new method for content safety classification using language models. My name is Mason Sawtelle. I'm a data scientist here with the applied AI team at Neudesic, and I'm here to talk to you about different methods for content safety classification, as well as our own new method that we've just published. While most content safety classifiers use a pre-trained model and fine-tune them on thousands and thousands of data points, our method actually involves using only as little as 100 data points. Existing language models used for classification of unsafe content often involve billions of parameters and many training examples in order to produce classifications that perform very well. What we've noticed with our method, called layer-enhanced classifiers, is that we're able to use models with a very small number of parameters, which is less than a billion, and we can achieve performance that beats GPT-4o and other flagship models in under 100 examples. Our approach uses two different types of content safety classification in order to prove that our LEC method works very well. The first method involves identifying whether a piece of content is unsafe from the frameworks of things like harmful content, discriminatory content, or things like that. The other approach involves identifying whether a user is attempting to change the behavior of the language model in order to use it for something that the creators did not intend. For example, if you have a financial advice chatbot whose job is to respond to users' inquiries, maybe about their balance, you don't want that to give homework advice to a college student. Our approach is able to use the hidden states of each language model in order to identify whether or not a piece of content is unsafe. What that means is that this can be directly integrated into an existing pipeline for a chatbot, or alternatively, you can use this pruned model with much less parameters in order to efficiently calculate the same exact tasks. Our research also shows that using language models as robust feature extractors applies to nearly every single type of model that we've experimented with. That includes things like Llama, that includes things like Qwen, as well as other smaller models such as BERT. Using previous research, we suggest that the vast majority of classifier-based tasks can be created to surpass GPT-4o in as little as 100 examples. In some cases, it even beat GPT-4 in as little as 5 examples. The implications of this type of research can even go beyond simple content safety classification. Other research has shown that this applies to any other type of classification task, including sentiment analysis, including categorization of different documents, as well as any other task. We believe that LEC has a lot of different applications across the spectrum of different AI tasks. This process can be applied to multiple different stages of a language model pipeline, including a pre-processing step where maybe unsafe user sentences are classified and rejected. This also applies to the output side of the language model, where the words that the language model is outputting can be identified as unsafe or off-topic and flagged. Additionally, we find that this hidden state can be used to identify different types of unsafe content, regardless of the actual system prompt that's being put into the model. What this means is that when a user sends in a single prompt to a language model, we're actually able to identify multiple different types of content safety at the same time before the first token is even generated from the language model. Due to the fact that these layer-enhanced classifiers work on top of an existing unmodified language model, we're able to use multiple different tasks and mix and match them depending on the use case. For example, a company can be using this LEC to identify unsafe content in their user-facing chatbots. At the same time, maybe their IT system can be using the exact same model and the exact same setup. It can be used to identify different IT tickets and sorting them into different buckets. We believe that the flexibility and the performance of these LEC models can improve content safety classification across the entire industry and can have numerous different impacts. Due to the flexibility and high performance of LEC models, we predict that this will have a large impact on the industry as a whole, and we plan on using them going forward in many of our different engagements. Thank you for watching. For more information, you can take a look at our blog post as well as our full research paper in the description, and make sure to like and subscribe.